Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 3rd, 2025, about 5 days ago. It introduces a method called TwinFlow that turns heavy multi-step generators into a one-step system, reaching a general eval score of 0.83 in 1 NFE and, on QNImage20B, matching the original 100 NFE model while cutting computation by 100 times with only minor quality loss. The paper is titled TwinFlow, Realizing One-Step Generation on Large Models with Self-Adversarial Flows, and as we'll see later, the implications for fast image generation are quite significant. Figure 1 gives a visual taste of what one-step TwinFlow generation actually looks like in practice. The large graffiti-style banner at the top highlights the claim that one-step generation is now feasible, which sets the tone for the method. Below, the collage of diverse scenes from city streets to animals and portraits shows that the model handles many styles and subjects with sharp detail. Together, these samples suggest that even with only 2 function evaluations, quality and variety both remain high. Figure 2 explains both how TwinFlow works and why it scales so well. The left diagram shows 2 mirrored flows, one from noise to real data and one from noise to fake data, and the method trains them so their velocities match, which creates a self-adversarial signal without a separate discriminator. The right bar chart compares graphics card memory, showing that prior distillation methods run out of memory on QNImage20B, while TwinFlow trains comfortably within a single high-end card. Table 1 makes the main simplicity claim concrete by tallying how many extra models each method depends on. A frozen teacher model means a large pre-trained network that stays fixed, while a smaller model tries to imitate its behavior. The first column lists common baselines like generative adversarial networks, diffusion models, and distribution matching distillation, many of which need at least one auxiliary or frozen network. The rightmost columns show that only TwinFlow achieves one-step or few-step generation, with 0 auxiliary trained models and 0 frozen teachers, which explains why the method scales so cleanly to very large backbones. This table shows that TwinFlow keeps image quality extremely high, while using far fewer function evaluations than competing multimodal generators. The large block of baseline models at the top reports general eval, DPG bench, and Y scores, which are automated metrics for image fidelity, prompt alignment, and style diversity. The middle rows compare faster distilled variants like QNImage Lightning and RCGM. The bottom TwinFlow rows stand out because they match or beat the strongest scores with just 1 or 2 function evaluations, so they deliver both speed and quality. Table 4 compares how fast and how good different text-to-image generators are, and it shows that TwinFlow delivers top quality with far fewer function evaluations. The upper block lists traditional multi-step models, which reach strong general eval and DPG bench scores, but run slowly because each sample needs many steps. The middle block reports few-step methods that still rely on auxiliary networks, so they gain speed, but with added training complexity. The lower block focuses on few-step methods without auxiliary models, where the bold TwinFlow rows achieve the best or second-best general eval scores at just 1 or 2 function evaluations, while also offering very high throughput and low latency. Alright, wrapping up, 2 takeaways stand out. TwinFlow turns heavy multi-step generators into 1 or 2-step systems without extra teachers or discriminators, and it scales all the way to massive models like QNImage20B with near original quality. That shift makes fast, high-fidelity generation far more practical. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.